Hey, welcome everybody. In our previous video, what we learned was how you can look at a parallelogram and determine some of the properties that must be true about that parallelogram. And in this section 8.3 and in this video, we're going to be looking at things from the opposite perspective. Instead of knowing that a quadrilateral is a parallelogram and then concluding, say, that its consecutive angles are supplementary, now what we're going to do is we're going to be given certain measurements of a quadrilateral and trying to determine from those measurements, is it a parallelogram? Alright, so the goal is that you will use measurements either for the sides, the angles, or the diagonals of a quadrilateral in order to determine whether that quadrilateral is a parallelogram. Alright, now I want to begin by discussing a couple ways that you can guarantee that a quadrilateral is a parallelogram. Let's say that you wanted to draw a parallelogram, and you wanted the simplest way you could think of in order to make sure that a quadrilateral is a parallelogram. Alright, well, one way would be, of course, just to make sure that the opposite sides are parallel to one another, because that's by definition of a parallelogram. But I want to discuss other ways besides just making the opposite sides parallel that can guarantee that a quadrilateral is a parallelogram. For instance, you know that a parallelogram's opposite sides are supposed to be congruent. Well, is every quadrilateral whose opposite sides congruent also a parallelogram? Let's find out. I'm going to make a couple of segments here. Let's say here's a segment and here is a segment. And then I'm going to copy those segments so that we have two pairs of segments that are equal to one another. Let me do that. Alright, here's a copy of the first segment, and here's a copy of the second segment. Well, there will be one there momentarily. There it is. And what I'm going to do is I'm going to put those things together to form a quadrilateral and show you then that that quadrilateral has to be a parallelogram. Now, there's really only one way to do this. I can't connect this segment at the end of the previous one because it just makes another segment, right? So I wouldn't be able to make a quadrilateral there. The only way I'll be able to make a quadrilateral with the two original sides that I had is if I connect this segment here and I connect this segment here. Alright, now because these two segments were equal and these two segments were equal, you already know that the opposite sides of this quadrilateral are both equal to one another. But does that guarantee that it's a parallelogram? Well, we do have this on a coordinate plane, and remember in a coordinate plane the way that you can show that the two lines are parallel is to show that their slopes are equal. And so we're going to show here that since the opposite sides are congruent, that makes the opposite sides have the same slope, and thus this is a parallelogram. Alright, you can see that the slope of this segment right here is 3, because it goes up 3 to right 1. And we just copied the other segment, so well, you can again very easily see though that it goes up 3 right 1 units. And then if we look at the top and bottom sides, you can see that the slope is -4/5. So if you go down 4 and you go over 5 units. And then the same here, if you start at this point, you go down 4 units, you go over 5 units to get to the other end of that quadrilateral. And so what we've done is we've basically shown that anytime you have a quadrilateral and the opposite sides are congruent, it's necessarily going to follow then that the opposite sides are going to be parallel, and so it's a parallelogram. Alright, make the opposite sides congruent, you've guaranteed you've got a parallelogram to one. Alright, a parallelogram when you make a quadrilateral. Another way to guarantee that a quadrilateral is a parallelogram. You might recall that a parallelogram's diagonals have to bisect each other. Alright, well, I'm going to draw two lines that intersect one another, and I'm going to make them intersect at their midpoints. Now, without launching into a proof of why it's the case, I hope that you can see that I do have these two segments right here, both with this point as their midpoint. Alright, see I'll go down 2, right 4, down 2, right 4. I can go up 1, right 3, up 1, right 3, meaning each half of those segments are congruent to one another. And what I want to do then is show you that if I have two segments that are congruent, and I try to connect the endpoints of those segments to form a quadrilateral, that quadrilateral is automatically going to be a parallelogram. So let's go ahead and connect the endpoints there. And then let's look at slopes again. All right. What I've done is I've created a quadrilateral whose diagonals bisect each other, right? And if you look at the slopes of the opposite sides, you'll notice that the left and right side both have a slope of -3. And at the top and bottom side, each have a slope of -1/7. All right, now let me kind of summarize what I'm trying to teach you here then. It turns out that there are 5 ways that you can guarantee a quadrilateral is a parallelogram, all right? 4 of those ways, well, 3 of those ways are using the sides of the parallelogram, and 1 uses angles, 1 uses diagonals, and all of these things that I'm about to teach you are related to the properties of parallelograms that you learned in section 8.2. All right, now for instance, by definition, if you can show that the opposite sides of a quadrilateral are parallel, that makes it a parallelogram. All right, so no question that makes a quadrilateral a parallelogram. But another way that's not by definition that you can prove that a quadrilateral is a parallelogram is what I showed you in the first drawing in this video. You can show that both pairs of opposite sides are congruent to one another. All right, and if you need something to support that, you can look at theorem 8.7, which makes that claim. And you can look at the proof in your textbook for theorem 8.7 actually. All right, so you can show that both pairs of opposite sides are parallel or that both pairs of opposite sides are congruent. That always guarantees that a quadrilateral is a parallelogram. A third way that you can use the opposite sides of a quadrilateral to prove it is a parallelogram is this. You can show that one pair of opposite sides are both congruent and parallel. All right, that just happens to be based on the information that you have. And you'll see an example later on where this is the case. All right, and that's theorem 8.9. I know I'm going a little out of order here, but theorem 8.9 is the statement that where this is proven. Now, I'm not asking you to memorize theorem numbers here. I'm asking you to memorize these facts, but I am giving you the reference for each of these facts in your textbook as well. Now, I mentioned that there's one way of using the angles in a parallelogram, in a quadrilateral to prove that it's a parallelogram. Although you might remember that there's 2 properties about the angles in a parallelogram. The way you can use angles to show that a quadrilateral is a parallelogram, other than things that we've already discussed here, is that you can show both pairs of opposite angles are congruent. All right, and that's theorem 8.8. Now you might recall that the consecutive angles of parallelograms are supplementary to one another, and so you might say that if you prove that all the consecutive angles are supplementary, that makes a quadrilateral parallelogram, and you're right, but essentially what that does is that proves that both pairs of opposite sides are parallel as well, so I'm not going to list that separately here. All right, and then there's finally the second drawing that I showed you. You can prove that the diagonals, or show that the diagonals of a quadrilateral each bisect each other, and that makes that quadrilateral a parallelogram as well. And that's based on theorem 8.10 then. Okay, so you got 5 ways of trying to prove that a quadrilateral is a parallelogram. Now, I'm not going to ask you to do a whole lot of actual proofs in trying to show that a quadrilateral is a parallelogram, but what I do need you to be able to do is analyze measurements in order to determine if a quadrilateral is a parallelogram, and that's what we're going to do in this next set of examples. You see the question, is the quadrilateral a parallelogram? Explain. And what I've done in each of these 4 pictures, all right, let's just look at these 2 for right now, but there's 4 of them total, is I've given you measurements or relationships between measurements, and I'm asking you to use those in order to explain, yes, this is a parallelogram, or no, this quadrilateral is not a parallelogram. And let's start with part A. All right, and you're going to notice in part A that what I've told you is that the opposite sides of this quadrilateral are congruent to one another, and that the opposite sides are parallel. Now, one more thing I forgot to say in the setup for this group of problems here is that the pictures are not necessarily drawn to scale. I've purposely made the majority of this picture so that it doesn't look like a parallelogram, but we're just going to use the properties to say is it a parallelogram just based on the properties that it has, not does it look like a parallelogram or not. All right? And indeed, if you have a quadrilateral whose opposite sides are both congruent and parallel, that makes it a parallelogram. Right, again, just forget what it looks like. I purposely drew this not to scale. So yes is our answer. And the reason for that then is we could say theorem 8.10 justifies that this is a parallelogram. All right? Because we've shown that one pair of opposite sides is both parallel and congruent to one another. All right, part B. You've noticed that I've marked that these two sides of this quadrilateral are congruent, and that these two sides of this quadrilateral are congruent. And indeed, a parallelogram would have two pairs of congruent sides, right? So is this a parallelogram? Well, not necessarily, right? In fact, we would say that it's not, because it's not the opposite sides that are congruent, it's the consecutive sides that are congruent. So our answer then is no, and our explanation is what I said exactly a moment ago. The opposite sides are not congruent, right? This distance and this distance are not equal. Doesn't matter that the consecutive sides are congruent to one another. Actually makes this quadrilateral a kite, which you'll learn about later, not a parallelogram. All right, so here's two more quadrilaterals that may or may not be parallelograms. I'd like you to go ahead and analyze them on your own, and then while the video is paused, say yes, it's a quadrilateral, no, and here's why or why not. And then unpause the video and hear my explanations. Go for it. All right, now in part C right here, you're going to see that this diagonal is bisected because I've shown you that each half is equal in length, but the other diagonal right there was not bisected because one of its segments was longer than the other portion. So no, the diagonals do not bisect each other. And that's that. If each diagonal bisected the other, it would have been a parallelogram. All right, and then for part D, turns out you should have said no here as well. That quadrilateral is not a parallelogram. And I would have accepted two different explanations for that. One of those would be that the opposite sides are not parallel, because the consecutive interior angles are not supplementary. 94 plus 81 adds up to 175, not 180. And same here. These sides are also not parallel, the left and the right, because their consecutive interior angles are not supplementary. So you could say no, the opposite sides are not parallel. But you could also prove that the opposite angles are not congruent, because if you added these three angle measures up and subtracted from 360, you would find that this fourth angle is 91 degrees. And so again, your other explanation could be that the opposite angles are not both congruent to one another. Even though one pair of opposite angles are congruent, not both pairs, and so it's not a parallelogram. All right, so now you know 5 ways to determine whether a quadrilateral is a parallelogram. You'll be expected to know those ways and to be able to analyze whether or not a quadrilateral actually is a parallelogram. All right, thanks for your attention, everybody. Appreciate it. We'll see you next time.